Good day! I am RD and I will be sharing about my thesis. Consider a balloon in an empty closed room with distinct gas particles. If we pop the balloon, we expect that the particles, which initially take the shape of the balloon, will eventually spread evenly in the room with velocities given by statistical mechanics. Indeed, after a long time, we will observe that the particles spread evenly, and the system has no memory of its initial state. It would not matter if the particles were initially in a differently shaped balloon or a different position. The balloon could have been heart-shaped, star-shaped, or even pentagonal. We would not be able to guess. But what if we have the same initial state in a different room? A weird room. Here, the gas particles spread for a while, but suddenly stop spreading. Even after a very long time, the system relaxes to a state where the particles don't spread evenly in the room. This system has memory of its initial state. I personally think that this would be a very interesting room. And this demonstration is actually an analogy for my thesis. What if instead of a room, we have a one-dimensional optical lattice with 3 sides? And instead of gas particles, we have bosons. This gives us a Bose-Hubbard trimer. Instead of gas particles spreading in a room, we have bosons hopping from one lattice side to another. We introduced disorder to the optical lattice potential and found that when there is 0 to weak disorder, the bosons spread evenly across the sides, analogous to the first room. Meanwhile, when disorder is sufficiently strong, the bosons don't spread evenly even after a long time. The system behaves just like the weird room. To hear more about ergodicity breaking in a Bose-Hubbard trimer, I invite you to my thesis defense on the morning of January 9. I will see you there.